everyone, welcome to another maths video by Maths with Sarah. So today we're going to be tackling a slightly tricky shape question. There's quite a lot that goes into this one actually. So whereas it might look simple to start with, there are quite a lot of different rules of quadrilaterals, circle theorems, trigonometry. The full works goes into this question. So as with all these questions, I really advise you to have a go at the question on your own first. Pause the video, have a little go. Even if you can't figure it out fully, if you can just have a think about what sort of what bits and pieces you might be useful to work it out, and then come back to the video and I will go through it fully for you. Okay, so lots of information to start with. We've got two tangents. We've got tangents to this circle. We've got the circle with the radius. We've got it forming a triangle. Various bits of information. We've been given the radius. We've been given the angle, and we've been asked to work out the area of this shaded region. So we've kind of got a kite shape formed using the tangents to the circle, and then we want to find out the shaded region. So the way that I always go about these shaped questions is I always think about what information we know to start off with. So before I start doing any calculations, I just need to think, right, what do I know? So I know that this here is equal in length to this here because they are both the radius. So therefore we can write that this length here is 10 meters as well. Okay. Then we also know that both of these are tangents, and if two tangents meet at the same point, so i.e. in this case we've got a tangent that tangent A and tangent C that both meet at point B, that therefore means that both of these are the same length. Obviously at the moment we don't know what that length is, but that doesn't matter. We also know from our circle theorems that if a tangent will always meet the radius of the circle at and form a right angle. So we know that this is a right angle and we know that this is a right angle. So we can then use that to calculate what this angle at the top is. So we know that the angles in any quadrilateral all add up to make 360. So if we do that maths, we get this as being 60 degrees. So we've got 90 plus 90, 180 plus 120. That gives us 300, which means that this last angle will be 60 degrees. Okay, so we've got quite a lot of information here. We've got to find out a few different things. We can either work out the total area of this kite shape, which is probably going to be quite difficult given that we don't know what this length is here. Obviously we could work out what this length is. That's one option. We could also maybe cut it in half, use some triangles. That's another option. So I am going to start by calculating the area of just this circle segment that we've got here. So in order to do that, we're going to find out the area of the full circle. So that would be pi r squared. So pi times by the radius, which is 10 squared. So this will give us 100 pi. But of course, we don't actually want the full circle. We only want a portion of it. So rather than having the full circle, we actually only want 120 over 360 60ths of this circle. This quite handily, I think, yep, this cancels down to just the same as a third. So we're going to have 100 pi times by a third, so that will give us 33.3333 recurring 30 pi. If I were you, actually, what I'd probably do is keep it as 100 over 3 pi over 3 pi, and that way we're not going to be introducing any rounding errors, because obviously as soon as you start to round it here, you then potentially cause yourself some problems later on. So that's the area of the circle segment. If you wanted to work out this in real terms so that you've got the right answer, I think it works out at about 104, 105-ish meter, that would be meters squared. Okay, so that is the area of this circle segment here. But obviously we need the total area as well, ideally. So the way that I suggest working this out is cutting the kite in half. So we cut it right down the middle. That's then going to completely bisect this angle, so cut it in half completely, so that makes this angle 30 degrees. And then this angle here is 60 degrees, because again, we've completely cut this angle in half. So that's 60 degrees. So we've got ourselves a triangle here, and it's a right angle triangle. So a right angle, we've got 30 degrees, we've got 60 degrees. So we need to try and work out ideally what this length here is, because then we're going to have the height and the base, and we can use those two measurements to work out the area of this half of the triangle and then the other half. Alternatively, we can just work out the length of this side, and then we can times these two together to give us the area of the total shape. Okay, so we're going to call this X, this side X. If we're going to be doing trigonometry, we're going to need to label the sides. So we know that this one is going to be the hypotenuse because it is opposite the angle. Now we need to figure out whether we're going to use 60 or 30 as the angle. Just for the purposes of this, I'm going to use 60 degrees. So that therefore makes this the opposite and this the adjacent. So now if we do SOHCAHTOA, we know that if we want to find out the opposite and we know the adjacent, that means we need to do tan. We'll use tan. So we always do tan of the angle. In this case, we're doing tan of 60 because we said we were going to use 60 degrees as our example angle. And we know that that equals opposite over adjacent. So in this case, we know that the adjacent side is 10 meters. So we've got tan of 60 equals opposite over 10. And then we know that this is what the side length that we've called X. So we'll put X in as well. So now we can work out that X is equal to 10 times tan of 60, which is something that you can easily put into your calculators. This is from a calculator paper, it's paper 2, so it's from a calculator paper, so you can use your calculator to work that out. If you pop that all in, then you get a value of 10 root 3. So just for now, I'm going to leave that as it is. So now if we want to work out the area of this total shape, same as if we were doing it for a rectangle or a square, because it's a quadrilateral, we can times the length by the height. Or alternatively, if you think of this as being the triangle, then we can times base by height, and then normally where we would divide by 2, we can either divide it by 2 and then times it by 2 because we've got two sides, or we can just do base times height. So we're going to do 10 for this side, 10 for this side, times by 10 root 3 for the other side. This then gives us a total of 100 root 3. Again, I'm going to leave it in this format for now, just so that I don't add in any rounding errors. And I'm not going to, I can either divide by 2 because it's to find the area of a triangle, and then times it by 2 because we've got 2 of them, or I can just leave that as it is. So we have now found out the total area of the shape, and we found out the area of this this circle segment. So now the last step that we would need to do to work out the overall answer would be to do the total area. So this would be 100 root 3, subtract the area of the circle segment, which we said was 100 over 3 pi. Again, or 100 pi over 3, doesn't really matter how you want to write it, they're both the same. And if we do that maths, we come out with 68.48532. Okay, but the question is asking us to give it correct to 3 significant figures. So we're going to want to chop the number here, because remember 3 significant figures includes the digits that are in front of the decimal point. So we include the 6, we include the 8, and we include this 4. But because this position here is greater than 5, then we're going to round this up. So we're going to call it 68.5 would be our final answer. And the units for that, because we're looking at an area, will be meters squared. So that there is our final answer. Okay, so that question, there are a lot of steps in there. I think the hardest part is realizing that you can cut this triangle in half and then cut the kite in half to make two triangles, which then allows you to use trigonometry. I think that's probably one of the hardest parts. The other thing is remembering just to use the your portion of the circle rather than using the whole circle, and also using trigonometry, remembering all the different rules. So as I said, we had to know that the tangent always meets the radius at 90 degrees. We had to know that these two side lengths would always be the same, so we've got two identical triangles. There are quite a lot of different steps in this, so I do think it's a really challenging question. It is question 20, so it's very near the back of the paper, so it's not surprising it's a tough one, but I really do think this is a particularly tough one. So yeah, let me know how you got on with it. If there's any other questions, if you've got any requests for questions or topics or anything, then do let me know. And lastly, thanks very much for watching. Please like and subscribe to the videos.